shouldn't. Then I need it. I know. Gone to the dark side. Okay. That's to chapter 5. Vicky in the Vol Shop made me get it. She said you have to buy that. Yeah, I'm trying to. I need it. I was up till 1 a.m. last night. I need it. I'm drinking less. Less is better, right? I know, Veronica. Yeah. Random question, but there's a chance you get on with Python. Oh. Maybe Clint, email me on that, Clint. And of course, as long as I'm allowed to help you, there's some packages for that, or at least R has packages. I can't remember the name of the R packages off the top of my head, but you're doing sentiment analysis, scraping Reddit. It sounds like another social media platform. Sentiment being like, how do people feel about things, and then cleaning some text, taking out stop words and stuff. Probably like end to the and scraping. It's outside of classes for a stock pitch. Oh, cool, Clint. Well. Send me info on that probably. So I won't do it here. Well, one, because I don't code in Python normally. I am a little bit of Python. But send me what you're doing. Like, send me it. Let me look it over. But we'll do a vote right now. For all who's here, should we do chapter 5, part 1 homework, or should we start doing chapter 5 quiz immediately? What do you think we should do? Yeah, Clint, that sounds like a fun project. Really good stuff. As long as I'm allowed to help you with it too. Make sure whatever you ask me to do, you're always saying to me, Brian, I have explicit permission to get your help for this. It's kind of on you. I have one question about the homework. Okay. We can do the full homework here. Oh, Charlie, we could do that. Oh, everyone's voting the quiz. Okay. Let's do the one question on the homework first. And give me the one question on the homework, and then it might be towards the end. I bet it's this one with the is it one of these, chapter 6 or 7? Or number... Give me the one question on the homework, and then everyone's voting quiz right now. So it looks like we're going to do the quiz, and we could do some chapter 5, part 2 quiz. And we could go over what p-values mean on rejecting and not rejecting the null. There's 2 parts to p-values, so I'll go over that. What was the question on the homework, Veronica? We'll do that one, and then we'll hop over to do quiz questions. So it'll be kind of a good, like, it's actually 4. Cool. No, that's good. This one's interesting. All right, so let's do and remember, if you're here, you get to pick what we do. So this is Stat 201, Chapter 5, Homework, Part 1, Question 4. Okay, so on this one right here, you have a company that's trying to speed up their calls. The first thing they want you to do is to convert these times from minutes to seconds, which is pretty easy because you have the median call is 4.3 minutes and the IQR of the call is 2.5 minutes. So all you do is just take these and times these by 60 seconds. So you do 60, that's not 60, 60 times 4.3 to get the new median, and the new IQR is going to be 150. Now, a lot of people get stuck on B, and I'll explain how part B is done. So when you're thinking about these calls right here, I want you to think about this. So it says we're going to speed up these calls by 18 seconds. Let's not pretend these are calls for a second. Let's pretend these are test scores. So if we had test scores, and you knew that the IQR, I'll explain it right here. So, and actually, I think it works better in a Word document. I'll explain why, because I've done these problems before. Okay. So you know that test scores have the lowest value of a 20. And what am I writing out right now? Can someone tell me these 5 numbers I'm writing out? What am I writing out right here? What am I writing out? I'm writing out the what? I wrote out 5 numbers, and I wrote out the what? What did I write out right here? 5 number what? For the min, the Q1, the median, the Q3, and the max. What did I write out? What's this called? Good review question. So what is this called? And start putting questions in the chat. We'll do more questions from Chapter 5 quiz right next. What is it called? It's 5 things. Don't worry, you can say, I don't know. I don't know is a good answer too. The 5-number summary, you're right. This is the 5-number summary often used to display box plots. The 5-number summary is what we use to, and it's not perfectly aligned right here, and great job, Lindsay, right there. The 5-number summary. Now, what it's saying in this problem is it's saying you speed everything up. So it's going to go down in the problem, it's time. So it's going to be sped up by 18 seconds. But let me ask you this right now. What is the current IQR. What is the current IQR? Just mathematically solve what the current IQR is. So what is the current IQR? What is the current IQR of this? Just mathematically solve it. Don't worry about the problem. We'll explain why this works this way. The current IQR is 20. So let's say I say, bad news, everybody. I misgraded the test. You all lose 10 points. If everybody loses 10 points, the new min is this. The new Q1 is this. The new median is this. The new Q3 is this. And the new max is this. What is the new IQR? New. The new IQR is now what? The new IQR is now what? Which is found by finding the distance between those two numbers. The new IQR is still 20. It's because the data shifts with it, like the Q3 and Q1 both shift in tandem with each other. So subtracting values would subtract from everything and not spread the data out more. Q1 and Q3 were reduced by the same amount and they're not spread out more. Adding and subtracting, so adding and subtracting does not change spread. Does not change spread. So for 1,000 points, what is another metric in this data that did not change? Think another metric of spread. What's up from Disney? Let's give a shout out to the Disney Data Analytics Conference. 5,000 points. Cullen there, bringing the pixie dust for us right there. What is another metric? The range. Random, good to see you there. The range didn't change also because that's another metric of spread. Although not found right now in this data, the standard deviation would not change because standard deviation is a measure of spread. And adding or subtracting would just shift data. Visually, adding and subtracting looks like you're doing this. If you add or subtract, it looks like adding, subtracting. And look, the data is not, you can put a number line down below here and like from 0 to 100. If you add or subtract, you don't spread the data out more. What would change the metrics of all the metrics? Not adding and subtracting, what would change all the metrics? Good for some of the Celsius and Fahrenheit problems. What would change all the metrics? Not adding and subtracting. That doesn't change measures of spread. What would change every metric? It would change spread and center and all those different things. Not adding and subtracting. Multiplying or dividing. Multiplying or dividing will change the measure of spread and the measures of center. So if you take your data and multiply it, it will spread it out more. If you take your data and divide it, of course, we're not saying divide by fractions, we're saying divide by like 5, you will tighten your data up. Does that make sense? So multiplying will spread the data out more and change measures of center and maxes and mins. Dividing will change other measures too, all the measures of the data. So when we do this problem right here, and really good question, I do like these questions. They're a little tricky, but the new median is going to stay, the median is going to drop by 18 to 240 because you're shifting the data downward, so the median will be subtracted, but the Q1 and Q3 are going to shift together, and since Q1 and Q3 shifts together, it stays the same. That's the answer. We don't have any more questions. Everyone says the quiz. What quiz question are we going to do? Okay. Drop the start of a quiz question in the chat. Chapter 5 is probably one of my favorite chapters of all chapters. So what chapter 5 question we're going to do? I love me some chapter 5. We're going to do tons of chapter 5. Tons of chapter 5. Part 1, 2 language majors. Yes. Which one did better? Good question. Maybe I should get one monster a week max. Thank you, everybody. 2 language majors. See, there's one about, no, that's a Z-score one. 2 language majors. And then I should do Charlie's question too about, here it is. I should do Charlie's question about kind of p-values and stuff. That's a really good theory question. Charlie, thank you so much. Charlie, 1,000 much for being here. Please drop more questions in the chat. Maybe we'll do Charlie's question next right here, and I'll put it in the video about theory about p-values. That's a kind of lecture type thing that I have to do right there. But drop more questions. We only have one question here. Quiz part 1, 2 language majors. Okay. Whenever you're comparing things, you usually try to turn them into whats to give them context. Whenever you're comparing things, it's best to turn them into what? Steve, oh yeah, yes, please, Colin, I'm excited to see you. I will see you Friday, Colin, and I will get you a coffee. Former student there, Colin, even broadcasted from Disney. So shout out to Colin right there. And check out the Disney. They've got things for students to do. They've got experiences and internships, I believe. So check it out. Yeah. You got it, Charlie. We'll do that one next. And we got answers in the chat, and the answer is z-scores. So we turn things into z-scores to give them context. Megan scored a 70 on the first exam and a 90 on the second exam. And then Anna scored an 84 on both exams. We have measurements on the exams that on the first exam, the mean was this and the standard deviation was this. And on the next exam, the mean was this and the standard deviation was this. So let's write down the first exam is normally distributed. This is E1. The first exam is normally distributed with a mean of 85 and a standard deviation of 4. And the second exam, E2, is normally distributed. We lost the normally distributed part of it. But they should have told us normally. I guess they want us to assume normally distributed. You should always say your data is normally distributed if it is. The second exam is lower with, what do you notice here? For 1,000 points, someone explain to me, what does this quantity mean right there? Ooh, Charlie's got a lot of good questions. The steer question, right? The second exam has a lower average with more what in it? The second exam has a lower average with more what in it? The first exam is higher with less variation. Ooh, good question, Charlie. More variation, higher standard deviation. This exam is going to look like this, and then the second exam is going to be lower with more spread to it. It's going to be more spread out, more standard deviation, more variation in the data. Standard deviation tells us a typical distance from the mean. So now what we do is we take each person, I'll put it over here on the right. So we go to Anna's first score. Anna got an 84 on this exam, and then we do observation minus mean over standard deviation. So she is equal to, on this exam, negative 1/4. Right here, 76. I'm going to run out of room. Here, I'll do the other side for the other student, Megan. So 76 minus 84 over 4 equals negative 2. If I make a math error, please tell me. So this is Megan's answers, and this is Anna's answers over here. And then we go and do the second exam. The second exam, also an 84 for Anna. Notice this is way above the mean. It's 14/15. So equals 14/15. And then for Megan, who has a negative 2 already, Megan on the second exam got a 95, way better. 95 minus 70, which is 25, which is going to be equal to 1.66, I believe. Okay, so what do they want us to do now? What am I going to do? If you notice, is it which one generally did better? To qualify for language honors, a major must maintain at least an 85 average across all language exams. So for which did they qualify? You must have an 85 average? Well, I don't think either of them did that. Oh, wait. So Anna didn't do it. This is a no for Anna, obviously. But 76, really? 76 plus 95 is equal to 171 divided by 2 to average it out. We're just averaging her two scores. We're averaging these two scores right here. And that is going to be equal to 85.5. So she did pass. You have to have an 85 average across both exams. So turns out Megan does qualify. So only Megan qualifies because she has an 85 average across both. You have to have an 85 average. So all we did right, Anna's easy because it's easy to calculate right there because she has an 84 average, so she wouldn't qualify because both exams 84. And which person did better? Here's the thing. When you look at this right here, tell me, I hope this is the one you're getting right here. Who did worse, Megan or Anna? Who did worse, Megan or Anna? Who did worse, Megan or Anna? And I'll tell you how I'm looking at this pretty easily. Who did worse, Megan or Anna? Yeah, you could just add them together. If you add them together, you will get a negative value over here, and you'll get a positive value over here. So positive z-scores means above, so you can just add them. And you can see the negative overtakes. That's what I see immediately. Probably add yours. This is going to be negative 0.33 or so. And then this, the 14ths, I guess you could find common denominators, right? That's a negative 0.25 and a 15th. Oh, I don't know my 15ths off the top of my head. It's basically 1. I don't know. This is going to be close to about 0.7, 0.71 or so. You can find out exactly what it is. Good question. So, and if I appear on the screen, then I will blank it out. So the answer is it's Anna who did better, unless I get it wrong. So Anna did better. Yep. The reason we use z-scores is it's like, imagine you tell your parents this. You say, I made an 80 on my test. Should your parents be happy? If you say, I made an 80 on my test, should your parents be happy? Yes or no? Trick question. So you say, I made an 80 on my test. Should your parents be happy? They should be. They should be proud parents no matter what. But imagine the test had an average of a 50 and a standard deviation of 10. So if you made an 80, what does this mean? If you made an 80, you're all the way over here. You are off the scale. You are in the top 0.15%. You are off the record. Does that make sense? So, but it could be that the average of the exam was a 90 with a standard deviation of 3.33. And if that was the case, then in the second example, you're all the way down here. Does that make sense? If the average is a 90 and you made an 80 and the standard deviation is this. So it depends, is like, what's the average of the exam? What's the standard deviation? Where do you fall in the distribution? And each of these exams has different context because we have one that is normally distributed with 70 and a standard deviation of 15. So an 80 here would be above average, but an 80 here is below average. Does that make sense? Like, if you made an 80 on exam 1, you were below average. If you made an 80 on exam 2, you were above average. So that's why you can't just add together the scores. So it's Anna who did better. I hope I didn't make any errors. We got it right. Yeah. So it's all about that notation, brother.
Notation, brother.
I guess notation, brother. Notation, brother. Okay. We might have chapter part 2 now. Charlie gave us some really good questions here. I think, are all yours from part 2, Charlie? We did 2 language majors. Speed of cars. Yep, I think it's part 2. Okay. Drop more questions. Drop those questions. Thank you, everyone, for being here. Let me throw you some more points. Chapter 5, part 2. We should. There's not that many for part 2, like questions. I think Charlie mentioned a steer one. Okay. NFL football season. I think he mentioned this one. Okay. So NFL football season is one of the ones we got on the list. And let's do it. And remember, just follow along, ask questions when you got them. You can drop some chapter 5 part 1 in here. Oh, I see another. Yep, there's the steer ones. We'll do the steer one next. We could probably almost do all of these because they don't take that long. So this one's kind of fun. The first thing you should always do is look at your data. That's what we like to do when we have data, is look at it. Oh my gosh. Tell me about this data. Who do you see in this data? Who do you see? Who's here today visiting us in class? You know who's here. It's very skewed. Monster Man's here. Get some points for Monster Man in the chat. We get a Monster Man. He's trying to blend in, trying to hide away, but we see you. Right to the high, skewed Monster Man. Right to the high, left to the low. Whatever way the Monster Man's tail goes, right to the high, left to the low. Right means high. So right to the high, left to the low, whatever way the Monster Man's tail goes. Okay? Let's do the question. According to the normal model, what % of receivers would you expect to gain more than 2 standard deviations above the mean? Now, it's not talking about our data. It's talking about the normal model. So if we have the normal model, what % of data would we expect to see above 2 standard deviations? So who can answer this in the chat? If we have the normal model, what % of observations would we expect to be above 2 standard deviations? I'm giving you hints as I draw this out. Always try drawing your normal curve. It's really good practice. What % of data would we expect above 2 standard deviations? That's the answer we're looking for right here visually. What % of data do we expect above 2 standard deviations? You're right, Veronica, right there. More points in the chat. 2.5 because you subtract from 100 to get the remaining outside portion of 5% and cut it over both sides to leave 2.5 in either tail. So that is 2.5 in the above 2 standard deviations. This one wants the context now. What does 2 standard deviations mean? Well, we can go and take this and we can go to the data. You see it says 508 is the average. So we go to 508 It does say above the mean. Got to check my numbers. And then we go up 2 standard deviation, 253.764. All I did was add 2 standard deviations. I added, and I hit enter again. So I added it twice. I just added 253.764 twice. And then there are how many NFL receivers? Well, it wants to know how many. What do you think I have to do to 508? Because we say I expect about 2.5% of them out of the 508 receivers. So I'd expect about 2.5% of the 508 receivers. So what do you think I should do to find out about how many receivers? It says round to the nearest whole number. Is it for both? I think for both. What do you think I should do when it'd be... if yours says 1, let's talk about that here. We'll talk about that next. What do you think I should do if there's 508 receivers and I expect about 2.5% of them? What do you think I should do? I mean, I expect about 2.5% of the 508 receivers, so what should I do? So there's 508 receivers, and I expect about 2.5% of them to do this. So how many would that be? What's the math? Don't overthink it. It's like I expect 5% of my students to pass, and I have 300 students. How many do I expect to pass? We can take the number 0.025 and multiply it by 508, and that's about how many we would expect, because 2.5% of the 508. So for yours, good question right there, Charlie. If yours is above 1, great job, John, right there, and 508 technically, because, yeah, just make sure to use the numbers. And think about this. If yours is 1 standard deviation above, make sure it says above, not below. If yours is 1 standard deviation above, what percent of data do we expect above 1 standard deviation? So what percent of data do we expect above 1 standard deviation according to the normal model? Oh, and then I'll show that again real quick, Veronica. Yeah. What percent of data do we expect if your problem says 1 standard deviation? What percent of data do we expect? Same sort of procedure, but using the 68 rule. 16 correct. And it'll be 16 on either side, but above 1 standard deviation. If it says below, it'd be 84. Just make sure whatever the question says. To do it properly, these numbers add up to 100. So what you want to be thinking about here is to find out how many yards it is. What we're going to do is we look at the mean, and we add 2 standard deviations. So I'll show again. The mean plus 2 standard deviations, because my question says 2, so that's 1 standard deviation, that's 2. Does that make sense, Veronica? You can also use our applets, and you can visualize it that way. I'll show you on the applet to show you visually what's going on right here. Make sure to round it to the proper number, but it's the mean plus 2 standard deviations. If you visualize it on the applet, you would simply put in your mean right here, a mean of like 500 or whatever it is, and a standard deviation of whatever the standard deviation is. And then you could look down here at the numbers on the bottom of the curve to see where 2 standard deviations is. These aren't the real numbers, but this is just a quicker way for me to visualize it for you, where the mean is at the center and you go up 2 standard deviations. You could also mathematically do, oh my gosh, wait, Veronica, I wasn't adding to the mean. I was adding to the amount of players. So wait a minute, the mean is 253.764. That's the mean, plus 2 standard deviations, which is this right here. Veronica just saved us. This is the answer, which rounds down. So there is the answer. Veronica, 5,000 points by asking me to re-go over it. I did not properly do my notation. And Veronica is even noticing now the error where this is the amount of observations. Thank you, Veronica. Good catch. Some big points in the chat. This is the amount of observations. This is the mean mu. And this is the standard deviation. I've done this problem a lot. I don't usually make that error. So there's the mu, and you go up 1 standard deviation plus 1 sigma plus 2 sigma right there. You're welcome, and thank you for clarifying. You might have saw that I was making an error right there. This is the mean is 253, and the standard deviation is 312. You can plug those into an applet or solve yourself by going the mean plus 2 standard deviations. Why shouldn't we use the normal? A, B, C, or D. You got this. Hopefully I haven't made any other errors. A, B, C, or D. I don't usually make any errors on these quizzes. On this one, chapter 5 is my favorite. The other one's it's not subjective. A, B, C, or D. It is definitely C. That is some right skewed monster man if I ever seen one right there. Veronica, huge thank you. Catching that error, I noticed it too. I was like, wait a minute, 508, that's not the mean. That's the amount of observations. Okay, we're going to do some steer stuff. Steer model. That's IQ. Weights of steers. Okay. Let's put this in the notes. The weights of steers. We'll do each steer problem right here. And 28, 53, stat 201, chapter 5 quiz. Yeah, Maddie, drop a question in the chat. We can do it. Okay. So here's what you do. You think really hard on these. You go like, I must think through these problems. And you go, okay, I got the answers in my head. I've got the answers. This one is going to be 1153. This one is going to be 90th percentile. Oh my gosh. This is going to be 1, 2, 3, 5. And this next one is going to be 101. I got one right. Let's show how to get the answers. Oh, good one, Maddie. Let's do that one here in a moment. Okay. I might be close on these, but let's see how to get the answers. I'm using my knowledge of the curve, and now we're going to look at it. You need to go to the apps. So you would not have this on the test, but you would have pictures of it. So you won't use this on the test, but you will use pictures of this. So take a look at the Canvas content to see how it'd be done. Now, whenever you're using the applet right here, the first things you'll enter in are the what and the what. Tell me the first thing you should enter into the applet. It's given up here. The first thing you should enter into the applet is the what. What is the very first thing whenever you're using the applet? Enter in the this and this. It's given at the top of the screen. In the notation, normally distributed with a blank and blank. What is the first two things you should enter in? The mean and the standard deviation. So the mean and the standard deviation. Now, when we talk about percentile, percentile means area where to a point. Percentile means area where to a point. The percentile, right there, Mubot has it pinned in the chat. So Mubot has the message pinned in the chat right there, how to get to this site. Click on Mubot's link. Thank you, Charlie, for asking. Area below a point. So if we ask for the 59th percentile, there it is right there, 114. I was not so close. But this is the 59th percentile as shown to you visually on the screen. The 59th percentile means 59% of steers are expected to have a weight below 1144. Now, was it the 93rd? Something like that. 93rd percentile, 93rd. Oh, I was so close. The answer for the 93rd percentile. On the test, you'll be given pictures. Check out the Canvas content to see exactly how they'll look. We could even do some of the Canvas content. But you need to understand what the graphic is showing you. That percentiles are area below a point. So the 93rd percentile is on the left or the right. Is the 93rd percentile, which means 93% of data is below it, on the left or the right? Is the 93rd percentile on the left or the right? Where would it be over here for the 93rd percentile? Because it means 93% of data is below a point. The 93rd percentile is where on the curve? The 93rd percentile must be on the right. Oh, don't worry, points in the chat. The 93rd percentile is on the right because 93% of data is below the point. Over here's the lower percenters. Don't worry about getting it wrong. We're throwing points for getting questions wrong here. Because when we say 93rd percentile, we mean 93% of data is below this point. So if you're in the 99th percentile, 99% of observations are below you. Does that make sense? That's what percentiles mean. So as you go across the curve from left to right, you go from the lower percentiles on the far side of the curve to the higher percentiles on the right side of the curve. So the last one here is the IQR. How do we find the IQR? Mathematically, the IQR is what? Blank minus blank. The IQR stands for the middle 50% found mathematically by doing what? Q3 minus Q1. So you could do that's Q1, which is 25% below there, and that's Q3. Or you could do this and do between, and look, the IQR is between these two numbers. And subtract, and if you look, it's about 101. I know a trick for it. It's about 1 1/3 standard deviations. So there is the IQR right there. Goes from here to here. Mathematically take these numbers and do Q3 minus Q1. And we'll do, I think there's another steer question. There's the answer, 101, which is the one I got right. The only one I got right by guessing was that. What? Did I mess up the 93rd percentile? Round to the nearest whole number. Let's double check our work. What did I do below? Oh, wait, does it say below a point? The 93rd percentile. What did I do wrong? 1, 2, 12, 38. How did I do that wrong? There's the answer, 1238. What did I do? So it's 1238. Did I not change the answer? There it is. So I didn't do it. Outliers. Ooh, we can look at that part 1. We'll try to do that. Let's see. Let's do one more of these ish. Those are very similar. Those are the same type of. Here, we'll do the other steer problem right here. Fixed it. Nice. Steer percentiles. I'm gonna do this steer problem, then we'll do another question immediately. So we're trying to spend like 5-ish minutes on a question. All right, chapter 5, quiz part 2, steer measurements. Sure. Nice to see you, Blake. Classic Blake. Blake in the chat. Good to see you, Blake. Can we get the normal curve website link? Yeah. If you type apps, Mubot will drop it in for you. So apps, and it's also pinned right there at the top. Mubot will drop it with apps. Mubot should put it in the chat. Or applet. Yeah, he responds like apps and applet. Okay. Blake hopefully has a bunch of points. I might need to put your points back on, Blake. You're welcome. Okay. So this question asks us, I got to give you points back, Blake. Those are real hours right there. Thank you, Blake. This question asks us first, what is the highest 10% of weights? But when we're using the applet, Veronica, say it again for points. What is the first thing we enter into the applet before doing anything? Before doing anything with the applet, we should enter in our what and what. When using the applet for these problems, first start by entering in your what and what. Mean and standard deviation. So we're going to enter in the mean of this and the standard deviation of this. Just taken from this notation, normally distributed with the mean and standard deviation. Now it wants the highest 10%. Is the highest 10% on the left side or the right side? The highest 10%, left or right. Is the highest 10% on the left or right side? There is a way to get it no matter how you do it. But generally speaking, the highest 10% should be where? You could type 10% here. And where should it be? On the left side or the right side? The highest 10%. The highest 10% of steer weights. Yeah, So when you say, like, imagine you say the highest scores on a test. Like, where's the highest scores on the test? They would be on the right side of the curve. Does that make sense? Now, when you talk percentiles, if you're in the 90th percentile, this is also the 90th percentile. The top 10%, good note to take, is the top 10% is the 90th percentile. Does that make sense? Which means 90% of data is below this point. So you could type 90 and find the top 10% by doing 90% of data is below this, meaning this is the top 10%. So if you're in the top 10% of the class, you're in the 90th percentile. And there's the answer. That is the top 10% of steer weights. Oh, I like guessing these. Well, we got a lot to do. The lowest, so same sort of trick. We just need to go to the left side of the curve. So we could literally just enter in 20 right here. And there's the answer for the next one. The applet ones, when you know how to do them, are so nice. As long as you don't make a typo error. IQ test, let's do that one. Then we'll hop back to chapter, the previous one. Let's do the IQ test. I'll do that one next here, Lindsay. Thank you so much, Lindsay. You've been here a while. You got it, Lindsay. The cutoff for the middle 40%, you see it says middle 40. So our graphic is going to have to show the middle 40. When you're practicing this, I would suggest drawing out your curve. The middle 40 logically has to look something like this. Because within one standard deviation is 68%. So the middle 40 is going to be tighter in. The 90th percentile is equivalent to the top 10%. Those are the same thing. So if you say, give me the top 10% of students, you're also asking, I want students who are in the 90th percentile and higher. Like, I need students who are at least the 90th percentile is the top 10% of students. and it would look like this to say the 90th percentile, something like this over here, the top 10%. Like, give me students who are at the 90th percentile or higher. 90th percentile is right there. That's where the 90th percentile is. And so with the middle 40%, we just go to our curve and we ask the applet nicely, please applet, go between and give me the middle 40. And the answers are currently displayed on the screen for us. And you can also round these to 1 decimal, or it doesn't do the bottom rounded. I'm going to type them in by looking at it over there. And we have 110.5 and 1197.5. And you can see the answers right there. Make sure your numbers are entered in the right way. And if you follow along, you should get 100. And we did it. Lindsay has a great question right here. Then we're going to hop back to chapter 5, part 1. There's the glass door one. Is it this one? I think so. I think so. Okay, Lindsay, what are the steps for this problem when you're solving right here? Yep, and I'll do one at the end of this, Veronica, that will look like a test question. So check out this problem, and then I'll make up a test question at the end of this to see if you are test ready with it. Is it not this one, Lindsay? Is it a different one? I'll find the other one if so. It says, can we do some IQ tests? Oh, it is different. Let me find. Yeah, it does. That's IQ, but not the right one. Thank you, Lindsay. Some IQ tests. Here it is. Found it. Okay. Okay. So this one asks, what is the IQ? Oh, what's the first step? The first step for solving a problem like this is to do what? The first step for solving a problem like this is to do what? Oh, no, again? We'll do this one real quick, then we'll find the next one. What is the first step for solving a problem like this? What is the first step? And then we'll find it. No worries, Lindsay. What is the first step? This one will be actually really quick. What is the first step for solving a problem like this? Go to the apps, and Veronica said it. So go to the applet, or apps, Muel will find it, and put in the mean and standard deviation. So we go right here, and we put in the mean of 100 and the standard deviation of 11. Now it wants the high. I love the applet too. Thank you, Adam Spanbauer, who made this right here. Shout out Spanbauer. There he is right there, Adam Spanbauer. So you go right here and you put in the mean and the standard deviation. Now the question asks us the highest 5%. So you have to think, if you're doing the highest 5%, is it on the left or the right side of the curve? Left or the right side? Well, it's the highest. So it'll be the right side of the curve. You can also round the numbers. It says 1 decimal. There's the rounding. And great job, Veronica. I feel like you've went from like these problems are tough to like easy. Lowest 40%. For the lowest 40%, you go right here and you just type in 40%. You think, well, the lowest 40 is going to be the left side of the curve, which you'd have to be below the mean of 100. So the answer is 97.2. And then the middle 80%, which is going to be more than 1 standard deviation, because 68 is 1, and we have to go out further. So you just do the middle 80 right here between, and the answers will be on the screen right there. There's the answers right there. I'm going to copy paste them or write them in. But the middle 80. And I'm going to do one quick question, then we're going to find Lindsay's question. Thank you so much, Lindsay. But here's how a test question could look. So use the following. IQ, so I'm going to write this in the chat. IQ has an average of 100 and a standard deviation of 10. Find the IQ of someone in the 90th percentile. Okay. But this is what we would give you on the test. So on the test, here's a tougher question. Okay. Sure, why not? This is what you could get on the test. This is a tougher question. What are you currently seeing on the screen? So let's say how test questions could look. Stat Tool 1, Chapter 5, Test Question Prep. Well, it shows you what you're seeing. You're seeing a what? What is this? I mean, it even says what it is. That's a what? The question is IQ has an average of 100 with a standard deviation of 10. Find the IQ of someone in the 90th percentile. So, I mean, that is a what right there. It says it. I don't know. What is this? then we're doing Lindsay. We got Lindsay's question right after. So thank you so much. I thought I found it, but we'll do that question. Well, what is that? The curve is showing us. It'll be going over what we went over last class, talking about decomposition models. Really easy quiz. It is a z-score. This is a z-score. Thank you, Mackenzie. Good question right there. So it's a z-score. With it being a z-score, think about this. What you want to do, like Joey said on Full House, is draw it out. So if we know the curve is normally distributed with 100 and a standard deviation of 10, what do you think I'm going to start writing below here on this first green mark? What do you think I'd write right there? You're on the right track, Veronica. You might actually figure it out. I'll show you the steps, but you might have figured it out. So below 0, exactly, Lindsay, we're going to put 100. And then we're going to put 110 here because that's one standard deviation. If you notice, you can see the answer has to be between what and what. The answer for this problem is between what and what. Just think visually. The answer for this, for whatever the IQ is of the 90th percentile, because 90th percentile means 90% of the data is below this point, which is 90% of IQs would be below this point. It has to be between 110 and 120. So logically, we're like, well, I mean, it has to be. What does a z-score tell us? A z-score tells us how many what's somebody is where. Just reviewing what a z-score is. A z-score means how many what's somebody is to the where. How many what's somebody is to the where. So that's a good review. A z-score means how many what's, so we can use an equation. How many standard deviations someone is away from the mean, exactly above or below. So all we do is we take the mean of 100 and we add to it the z-score of 1.3 times the standard deviation of 10, which I think you guys are doing, guys, gals, pals, doing in the chat. And this is going to equal to 113. So you put in, you just go, that's how many standard deviations go. And it looks like that's about 113. Yeah. So we could give you graphics like this and ask you, what is the IQ of somebody in the 90th percentile? Another trick we sometimes do is we do it like this, where now you see like the bottom 10% and you have to flip it. Does that make sense? Like you could get this and be like, oh, this is the bottom 10%. I want the top 10%. And that would just be on the other side. Like the 90th percentile is the top 10%. Or you could get this and you'd have to know the top 10% is where the 90th percentile is at. So you have to know what you're looking at and be like, okay, if this, I'm looking for the 90th percentile, it would be right here. Because if this is the top 10%, then 90% is below here. Or we could do this and you'd be like, okay, if this z-score is negative 1.33, where the bottom 10% is, the top 10% will be on the other side. Is that making sense, the kind of tricks we can play with these graphics? We can make it in z-score format. We could give it to you another way. You just have to know what you're seeing. And a lot of times just drawing on it and being like, well, what information do I have and how can I use this can really help with solving it. People feel a little bit better. Let's go find that IQ question, some IQ scores. We will find this question. Lindsay, we will do the question. Where is it? Wait. So when asking about someone's value, their grade, IQ, it's asking for the observation. Yes. Yes, probably is. That sounds like it's asking for an observation. Lindsay, do you see it? Is it this one? Tell me the number if you see it. Or is it a homework question that somehow isn't on here? If you see the number, be like, number this. Because I'm not seeing it. If you want to pick another one, tell me another one. Oh, it's part 1? Okay, boom. Going back to part 1. This is why we didn't see it. Back to part 1. Back. Whew. Man. Chapter 5 is so cool. It's like the fundamentals of statistics right here. Very, very, very important chapter. Some IQ scores. Glass door. Tiny Brown. Blake knows. I'm Tiny Brown. Woo! Oh, man. Some IQ scores. Oh, this one tricks me. That was part 2 a lot we were doing right there. Study outliers. Oh, Isabel, you got to go in right here. Part 1. Thank you. We'll do Isabella's question next. Um, okay, 4823, Stat 201, Chapter 5, Quiz, Part 1. Some IQ tests. So this one right here, when you think about what is unusual or usual in doing standard deviations, 1 is typical, 2 is odd, and 3 is ridiculously odd. We could go back and do some homework, Maddie, too. Yeah. So 1 is typical. Like, it's not like, think about heights of guys. If you have a guy friend who they tell you, I'm really tall, you'd be like, really? And the typical guy is 5'9" and has a standard deviation of 3 inches in their height. So if your friend is 6 feet tall, are they like super tall? Yes or no? Your friend's like, I'm super tall. I'm 6 feet tall. Are they super tall? Is a guy who's six? Good to see you, Reptar. Is a guy who's 6 feet tall. So this is the observation Y, and this is the Z-score. Are they super tall? Nah, that's not that tall. That's like above average. If they're 6'3", are they super tall? That's a Z-score of 2. You notice we're going up 1 standard deviation. If they're 6'3", is that like super tall? It's 1 standard deviation, 1 standard deviation. We'll go with another. Is that like super tall? That's where your back starts to hurt. At least mine does. It's not super duper tall. If you see a guy who's 6'6", Dale walks in here. I don't know if I like Dale. Dale seems all right. Dale won me back over. He stood by Cat. That's what I say. Yes, I'm a fan of Bachelor in Paradise. Come out and say it right here. Dale won me over. Sean didn't. No, I'm sorry, Sean. Don't give anyone hate, but see that. Don't do that. That's pretty darn tall right there. So you go from being, if you think about what these mean, 1 is like, tall. 2 is like, tall, and 3 is like, whoa. Does that make sense? Each standard deviation kind of denotes like kind of tall, very tall, extremely tall. And it's subjective on how you describe these, because it's not like 2.9 isn't extremely tall, like someone who's 6'5.7" or something like that. It's not like, oh, you're not extremely tall. It's a gradient. Who follows me? The more standard deviations you are away from the mean, the more unusual you are. And this goes to how the curve looks, that as you go up 1, 2, and 3 standard deviations, this is where the extreme would be over here on the far side, extremely tall right there. And so the same works for this data. It wants to know, where is, just the way they describe it sounds weird. I think it's this one. I think it's this one. Let's do it. So this is 2 standard deviations. So we merely go and take the data and do 2 standard deviations, add it to the mean, and do 102. So there's 2 standard deviations. And then we simply take and add another standard deviation to it. And now we have this. Because you would really rarely see something 3 standard deviations above the mean. 2 standard deviations is unusually high. And 3 standard deviations is extremely rare. The way they describe it's a little bit weird. But just think like 2 is very unusual and 3 is extremely unusual. 1 is kind of high. It's not like really high. It's like, yeah, it's kind of high. Then we had another one from Isabella. Study looked at outliers from an average of wind speeds. How's everyone doing today? I do like asking that. Everyone having a good day? It's all right if you're not. That is valid. Not having a good day is valid. I'm running over my cords. Ah! Not having a good day is valid. You share it and you get it out of your system. You're like, my days. I've been having a good day though. Having a good day. I turned in my test. Turned in my statistics test. Yes, I take a statistics test. Chapter 5, quiz, part 1. A study looked at outliers. So this one deals with changing data right here. Oh, it's Z-scores. I thought it was a different question. So here is the mean and standard deviation for the data. Let's take a look at it. There's means and standard deviations. So let me ask you this. Is these wind speeds? I don't care about wind speeds. What was the month that was on average the windiest? What month was on average the windiest? Like had the highest wind speeds? What month was on average the windiest? You can abbreviate it in 3 letters. Just looking at the data right here, just knowing what you see by looking at this. What month was on average the windiest? What month was on average the windiest? Thoughts? February. Yep. On average the windiest with the most variation. Great job. He gets Skeletor for that. He's happy. Definitely February on average the windiest. And now we're going to take the outliers for the months respectively. So we could add in an observation for an outlier, like outlier observation. So Y sub O for outlier. Great job, Isabella and Lindsay and Veronica. And we would put in the values of 6.726 and 3.931 and 2.527. So we're going to have to run this through observation minus mean over standard deviation. So technically what you could do is you could write, it's so hard to, let me change that thing. I'm going to try to make it so I can like write these side by side. Okay, and then we'll go here to the black pen. And you go observation minus mean over, wait, you have to do it on the other side. Because it's observation minus mean. Let me know if this makes sense that I'm doing this right here. I'm going to go, who follows what I'm doing? That I'm taking the observation down below and doing observation minus mean over standard deviation. And then for the next one, it has to be observation minus mean over standard deviation. And then observation minus mean over standard deviation. Yep, yeah. So I'm just plugging in the numbers, and we have to find each of the z-scores. Does it, so literally, and so there's everything right there. I'm going to put it over here, so I'm going to have to do the math. Just don't make math errors. Easier said than done. Easier said than done. Because everyone's going to punch something in and be like, no! Oh, that's close to a number I know. Okay, this is the z-score for this. And 2 decimals. Observation minus mean over standard deviation. Okay, that's more unusual. And then the last one, we're just literally solving this last equation right here, which I had to read 2.527, 527 minus that observation minus mean over standard deviation. 2.527. That's right? Yep. Minus 0.629. Oh, this one's going to be a little bit more than 3, so it's not the biggest. Okay, as long as we didn't do any math errors, fingers crossed. As long as we didn't do any math errors, the most unusual month is June. And we didn't do any math errors. Yeah. We like not doing math errors here. So once again, this problem is a find z-score multiple time, observation minus mean over standard deviation. So I kind of reworked this. I wrote the observation for each month for the outlier. That stands for outlier observation. I know, right? It's so easy to make a math error. It's so easy to just mistype. But just observation minus mean over standard deviation, observation minus mean over standard deviation, observation minus mean over standard deviation. This was the mean, and I just rewrote the table so I can include observation minus mean. The formula, once again, for z-score is observation minus mean to get the distance over the standard deviation. So the top of the formula is the distance, and the bottom is standardizing it to units of 0, 1. Where, yeah. More questions. We got time for at least 2 or 3 more. What do we got? Any more questions? What do we have? Let's see. Let's see. There's my schedule tomorrow. I'm sending it over to someone real quick. Would 3:45 work or earlier in the morning? Companies who design furniture. We do both. Can Environmental Protection Agency? Yes. I'm scheduling the meeting while we're doing this. Oh, this semester's so busy. So busy. Got to multitask. Can environmental... This is chapter 5, part 1, right? Environmental Protection Agency. I do like this one a lot. Multitask. You got to solve problems and schedule meetings. Chapter 5, quiz, part 1. Environmental Protection Agency. And I see another one. Sounds like I sing. Okay. How does the curve work when you draw the curve? 68, 95, 99.7. But what goes in the center of the curve? 68, 95, 99.7 is the area contained within 1, 2, and 3 standard deviations. We'll do the Alpine. That one's a good one. We got 2 from Charlie. We'll do those next. So what goes in the center of the curve? The center of the curve has the what? When drawing this out, the center of the curve has the what? And you should practice drawing this out by hand. So you should be like, gotta make the sound effects when you do it. You gotta be like, ka-chow. What goes in the center of the curve? What goes in the center of the curve? Well, I mean, it's the center of the curve. Well, like what mathematical value should be at the center of the curve? The mean. And it looks like they did this properly. So that did not narrow it down. But now we need to go up and down 1 standard deviation, which is this value right here. So that'll be 1, 2, 3, 1, 2, 3. So we're looking at a distance of about 6. This is not a distance of 6, as in I'm looking at this right here, and this is not a distance of 6. So this one is wrong. This looks to be about a distance of 6. That's right. This is way too big. That's not a difference of 6, so this is wrong. As is this one right here, way too big of a distance, not a distance. So the answer has to be this one. It looks to be about that distance of 6 for the standard deviation. So the answer must be this answer right here. Now it's going to use the 68, 95, 99.7 rule to do this right here. So we can use this graphic, and we should be able to draw it out once again. Practice drawing out your normal curves to know how to do it. You can't bring it to the test, but you can use the normal curve if you can draw it out on the test, because you have the knowledge then, and knowledge is power. So with this right here, the first question asked the middle 95%. Oh, come on. We got the answer on the screen. It's going to be between here and here. So that makes the answers right there, the middle 95%. And I might bring this over to the side so I can see the answers as I type it. The middle 95%, as shown on the screen, make sure to look at the correct graphic, is going to be between these numbers right here. Next, I want you to answer about what percent should get more than 30.95. If you look at where 30.95 is, what percent should get more than it? Who can help out with this question for 1,000 points for everyone in the chat? We'll show how to get the answer in a moment. Remember, you have to have the right graphic to get the right answers. What percent are expected to get more than 30.95, which is this right here? Well, it's not the other arrow I'm about to draw, but that's a help. What percent are expected to get more than 30.95? Got Veronica, you got it. Because if there's 68 inside, that leaves 32 total outside, because that's 100 minus 68 to get the remainder. And then you cut it in half, which means 16% in either tail. Great job, Lindsay, also. So the answer is clearly 16%. Also make sure it looks like 16%. If it doesn't, you might have done something incorrect. Wow, did it. And now, let's look at the next question. I'll have you do this one also. Might be tricky. Between 30.95 and 37. This one. So remember we just found one moment ago that this is 16% total, as in all of that is 16. So is this going to be more or less than 16? What do you think? Is that area now going to be more or less than 16 if 16% is from here over? We only want between these two areas right now. We want between here and here. Is that more or less? And I'll show how to solve this one because we only have like 10 more minutes. It's going to be less. Well, what we have to do is the big arrow, small arrow trick that I mentioned. This is going to be the area outside of 95. 100 minus 95 is 5% because 95 inside, 5% remaining outside. cut it in half for the remainder in the tails, and then you subtract off the remaining 2.5, which is over here. So 2.5 is in the yellow tail, and it would intersect with the area there. But when you chop off the 2.5, how much is left in this area right here? 13.5 exactly, found by subtracting those two numbers. Great job right there. The answer is 13.5 for this one. I love these questions. Last but not least, we have the worst 2.5% of cars. Well, here's the thing. We already kind of did it. The worst 2.5% of cars is found where? We kind of did it a moment ago. Where's the worst 2.5% of cars? Do you see it on the screen? The worst 2.5% of cars is going to be found where? I'm erasing down to where we can see it. The worst 2.5% of cars is down there. So the answer is 12.38. Great job. Yep, and the more you mark the curve, the easier it gets. So they would get less than 12.38 because they're the worst cars. You're right, it is on the left side because that's not, and that is the 2.5th percentile, and it's on the left side. You are correct. The high side would be the best cars. The left side's the worst cars. Briley right there, 1,000 points. You are correct. The worst cars on the low side, the lower percentiles for gas mileage. And it might matter the context of it. I think we've got time for at least two more. So let's try to do it. Charlie's got, let's see, company who designs furniture. These are all from part one, right, Charlie? Oh, it's the 5th grade design furniture one, right? Wait. Not that one. It's rivets. The rivet ones has a trick at the end. The rivet one has a trick. We did the major one. Is it chapter 5, part 1? Someone said shoe sizes. We haven't done that one. That one's a little bit different. I do shoe sizes. Maybe Charlie, part 2. Okay. Let's do a part 2, and I might come back and do shoe size question. That one's a little different. Got a trick to it. Let's do shoe size, because that one tricks people. Part 2 is not due tonight, correct. And so, and there are a lot of these. I've done a lot of these online. And I like that some of them are here. We've done a lot. We'll do the shoe size. We'll need to end with that. Company designs furniture. Cool. So this, let me mark it. This is an applet question. Someone dropped the app in the chat, and I'll give you 1,000 points. So have Mubot tell us where the app is at as I type the question. Have Mubot drop the app in the chat. Applet. So companies who design. 1,000 points right there. So Mubot's dropped the app in the chat. We're going to click it and head over to the app. Now, whenever you go to the applet, which you do need to know how it looks at on the test, how to look at it, the first thing you should do is enter in the mean and the standard deviation. So we're entering in the mean and the standard deviation as given in the problem. Now, there's two ways to use the applet. You can find a value using the probability or find a probability using the value. I think this question does both of them. So the question first asks, about what fraction of kindergartners are expected to be less than 33 inches tall? So notice, I'm going to enter 33 right here, and I'm using find the probability using X, and I go below. Something's wrong. Well, let's find out. It might be right. I think for the first time in a while, it shows something so far off the curve because that is more than 3 standard deviations. Let's go to a third decimal on this. Basically, none of the students. Yours might not be so far off the curve. You can barely, 33 is barely viewable. If you zoom in, you can see where 33 is at. Does that make sense? It's way off the curve. You'd have to zoom in there to see 33 in like 1 in 1,000 kindergartners. I don't know if it wanted that many decimals in the answer. Rarely have I seen it that small. And notice it wants it to 1%. It might have accepted 0 with the rounding issues. In what interval are the middle 80%? So when doing the middle 80%, we're not finding a percent. We are going to find the values using the percent. So we switch over to the percent or find the values. That's what X means, using the percent and go to between. Notice right here, and we can go to 1 decimal on the rounding, and it'll round for us. Won't round these numbers. I wish it did. But does this make sense? Give me a yes or no in the chat if you follow along, that you're using the applet to put in the mean, the standard deviation, and we're finding X using a percent right there, which is a p-value. So the middle 80%, make sure you have middle selected 80%. Make sure your graphic makes sense, that you're seeing the middle 80% on it with the mean and standard deviation accurately displayed on the screen. So I'm going to bring it over here. Yes, Veronica's like, oh my gosh, what's going on? So the middle 80% is 36.8 to 41.6. And the last one says the biggest 30% of kindergartners. So there's one way to find this. You could go to the top 70 or the 70th percentile, or you could just do the biggest 30% right there. And notice it's the same answer because the 70th percentile is the biggest 30. So 40.2, as long as it wants to 1 decimal, we should get everything right. We did. I think it should accept 0 for this. It did, because it was a very, very small number. Glad this one's a little tricky. We did it quickly. I want to get to the shoe size one, chapter 1, part 1, whatever we're doing. I don't know. We got a lot done. Woo! I'm glad people are here. I'm glad people find these helpful. Remember, just come to office hours and ask for your question. If your question didn't get completed, just keep dropping it, and I'll see it, and I'll be like, okay, let's do it. Problem. Especially if multiple people say it. I saw the shoe problem like twice, so I'm like, we gotta do it, and I know it's tough. I do have a video for that one, Charlie. I might have enough time on it. I do have a video going over that one. We'll see. We'll do that one next if we finish by 2:15. I think I can get it done. I want to explain this one fully. Let's try, because I teach here in a little bit. Ah! Where is, it's the temperature one, right? This one's like a class of problems. Like there's certain problems that ask you to do certain things. So how does it start? It's like the temperature thing, right? We'll do more. We'll do, oh yeah, we'll do tons more chapter 5 part 2. Tons more chapter 5 part 2. Shoe size, here it is, shoe size. This is the one. Okay. We got enough time, Charlie, because this one's shorter than I thought. Oh, what was the last one we did? We did, oh gosh, what did we do? I didn't mark it. I put everything down on it, but we just did, Charlie, which one did we just do? Man, I'm like, furniture, elementary furniture. There it is. Oh wait, I already marked. No, it's this one. Okay, I got this question set up, and then I didn't get to the question. Okay. Okay, let's do this. This question is: a study was conducted, European shoe sizes. With this question on European shoe sizes, it's having us convert the data. Now, this question goes to a lot of things about shifting and scaling. So I want to explain to you how shifting and scaling works with data. So take a look at this data right here. The original data had a median of what? I just want you to tell me you're looking at it right now. The original data had a median of what? The original data, which is the top data, had a median of what? Just I want to see you're looking at the data. That's all I want to see. The original data had a median of what? The original data had a median of what? The original data had a median of what? What did it have? 80. Now, here's the thing. For some reason, the professor, not a nice guy, decided to take 10 points off everyone's exam. Notice that the median is impacted by this. That's because when you add and subtract, it'll change all these locations. Adding and subtracting does the following to data. This is adding and subtracting. It changes measures like mean, median, min, max. But it doesn't change the what of the data. Adding and subtracting, think of an S word, doesn't change the what of a data. This is not adding and subtracting. This is multiplying and dividing. Adding and subtracting doesn't change the what of data. This is multiplying. This is dividing. Adding and subtracting doesn't what your data out more. Adding and subtracting, multiplying and dividing. Like you're timesing by 3, 4, 5. Is spread, which standard deviation is a measure of spread. It won't change any measures of spread because look, if you subtract 10 from all the values, if the IQR was originally 20, what is the new IQR down here? Because we've subtracted 10. It was 70, now it's 60 for Q1. It was 90, now it's 80. What's the new IQR for the new data set where we subtracted 10? So you're just subtracting 10 from all the values. The new IQR is what? The old one was 20. The new one is what? The new IQR down here is what? The old one was 20, which is the distance between Q3 and Q1. The new IQR is what? For the new data set where we subtracted 10 from all the data points. Because you can just subtract 10. It's still 20 because IQR is a measure of spread. Remember, standard deviation is for normally distributed data, and IQR, which you can use, but it's more commonly used for skewed data. So let's look at this right here. It wants to know about the mean. Is the mean impacted by adding and subtracting values? Yes. Is the mean impacted by multiplying and dividing? Yes. So what we would do right here is we'd take the original mean and just run it through the formula because it's going to be impacted by multiplying and adding and subtracting. So we'll take 44.17 and times it by 0.79.48, and then we will subtract 24.7, and that's the new mean. Then the standard, and we got to go to 2 decimals. The standard deviation will not be impacted by what? The standard deviation will not be impacted by what? You remember this little lesson we just did a second ago? The standard deviation is not impacted by whatting or whatting, because that does not spread the data out more. The standard deviation is not impacted by whatting, or whatting on values. It won't spread the data out more if you this or this. It will change the mean. If you this values or this values, which we went this way on this one because we did by that. If you what? Measures of spread are not impacted by whatting or whatting to the original values. Who knows? Measures of spread are not impacted by whatting or whatting. Adding or subtracting. Adding to them or subtracting does not spread the data out more. If you add or subtract, good guess, Reptar, and good, you're basically right. Adding or subtracting does not spread the data out more. It will change the mean, which is a measure of center. So to figure out what the new standard deviation is, multiplication will impact how spread out the data is. Multiplication, in this instance by a fraction, would make the data less spread out, decrease the standard deviation because it's less than 1. So we take the original standard deviation of 2.06 and times it by 0.794, and that's it. We do not do the adding and subtracting, and that should be right. There you go. Because adding and subtracting does not change measures of spread, but the mean is impacted by multiplication and adding and subtracting. Because this is, think about where the center of the data is. If it's right here, if you add, you would change the center, and if you multiply, you would change the center. Think about if you're looking at how spread out the data is, if you subtract, you don't spread the data out more. Like, we're just thinking how spread out it is. But if you divide, you make the data less spread out. So adding and dividing do not change measures of spread, IQR, range, standard deviation. They will change measures of like the min, the max, things like that, which isn't a measure of spread. So that's a good question. Good theory questions. They're kind of tough. They got me like the first semester. I thought, I was like, what? 15 years I've been teaching now. 15 years. 15 years! Okay, we are going to speedrun. Charlie's still here, and thank you, Charlie. We're going to speedrun this last question. My gosh, I got to speedrun it. Okay, we got one last question here. We're going to do the downhill skiing, and we're going to speedrun it. We got this. Oh my gosh. They changed it a little bit. They made it a little more difficult. Speedrun time! Let's do this. Last question of the day right here. Stat 201. Chapter 5 quiz part 2. 53 men completed the downhill skiing. Okay, so the first question right here is asking if the normal model is appropriate, then what percent would we expect to get times greater than 108.14? So I'm pretty sure 108.14, if we subtract the mean and divide by the standard, ooh, really? Dun, dun, dun. That's the z-score. It's applet time. Let's go to the applet here. So we're going to go to the applet, and it says what percent of times will be greater than this. So by going to the applet, remember the first thing we do on the applet is we put in our mean and standard deviation. So the mean right here is 103.90, and the standard deviation is 2.65. And then it wants to know what percent are greater. So we're going to find the probability using x than 108.14, and we go above, and we find out to how many decimals? 0.55 or 5.5%. This did not fall on a nice perfect number. It used to. Round to one decimal, about 5.5%. In actuality, what percent of times are greater than 108.14? We have to look to the real data now. In actuality, 108.14 is going to be right here. And remember, it said 53. So that is 5 out of the 53, which is a little bit less than 10%, something like 9.7. 5 out of the 53, 9.4. So in actuality, it's 9.4 times that are greater, 9.4% of the times. Why do these percentages not agree? Well, if we look at this, there's kind of a buildup here at the start. Is it skewed in what direction? There's a lot of 102s. This might be right skewed. Because if you look at, I think it's right skewed. I'm doing it quickly. Because there's that many 101, that many 101s, 102s. I should do different colors. 104s, 105s, 106s, 7s, 8s. Yeah, it's more of a right skew because it kind of goes like this and then goes out where the 101s, 103s, 104s, and such on. There's just a bumpish down here, and then this is where they're more outliers. The outliers are on the right side over here at 111 or so. So it looks like it's a right skew Monster Man as far as I can tell if you were to go through and draw it out. So you could do it in Excel. It's going to be a right skew. Oh, it's not unimodal symmetric. And then we said it's more right skew from the data that we drew. That looks like my Monster Man I was drawing right there. And what can be seen? Monster Man right skew. Let's hope we got it right. Yeah! What do you think, Charlie? Was that all right? Make sure to put it into the applet right here. So for that first one, you have to go to the applet, and you have to solve using the applet. So the first one is putting it into the applet and you have to put in your mean, your standard deviation, your number, and do above. And then the second one is doing the actual data, the actual amount above whatever it asks. And I had 5 out of the 53 total times because it said there's 53 total. Does that make sense, Charlie? I know I sped run it a bit. I do have more videos on this, and we can do it next time because there's more of Chapter 5, Part 2. I have class in 7 minutes. Can you explain p-values quickly if you have time? We'll do that next time because I have 7 minutes to get to class, basically. Until next time, we will do that, Charlie. Thank you so much. Bye for now, everyone. Bye!